There are different categories of machine learning techniques for different types of problems. The main categories we'll discuss are classification, regression, cluster analysis, and association analysis. In this video, we'll go over each of these in detail. By the end of this video, you should be able to describe the main categories of machine learning techniques and summarize how supervised learning differs from unsupervised learning. In classification, the goal is to predict the category of the input data. As an example of this is predicting the weather as being sunny, rainy, windy, or cloudy. The input data in this case would be sensor data specifying the temperature, relative humidity, atmospheric pressure, wind speed, wind direction, etc. The target, or what you're trying to predict, would be the different weather categories, like sunny, windy, rainy, and cloudy, as we discussed. The categories to be predicted are called classifications. Another example is to classify a tumor is as benign or malignant. In this case, the classification is referred to as binary classification since there are only two categories. But you can have many categories as well as the weather prediction problem shown here. Another example of classification is to identify handwritten digits, as we talked about in our last video, as being one of 10 categories, 0 to 9. When your model has to predict a numeric value instead of a category, then the task becomes a regression problem. An example of regression is to predict the price of a stock. The stock price is a numeric value, not a category, so this is a regression task. It is not a classification task. If you were to predict whether the stock price will rise or fall, then that would be a classification problem. But if you're predicting the actual price of the stock, then that's a regression problem. That is the main difference between classification and in regression. To summarize, in classification, you're predicting a category, and in regression, you're predicting a numeric value. Another regression application, in addition to the stock example here, is for prediction of the amount of rain for a region. Recall that in our discussion on classification, we had discussed predicting if it will rain the next day. That is predicting between one of the two categories, rain or not rain. So that's a classification problem. But if we are predicting the amount of rain, which is a numeric value, that would be a regression problem. In cluster analysis, the goal is to organize similar items in your dataset into groups. A very common application of cluster analysis is referred to as customer segmentation. This means that you're separating your customer base into different groups or segments based on customer types. For example, it would be beneficial to segment your customers into seniors, adults, and teenagers. These groups have likely different likes and dislikes and have different purchasing behaviors. When companies segment customers into different groups like this, they may be able to provide targeted marketing ads for each group's particular interests. Note that cluster analysis is also referred to as clustering in different contexts. Next is association analysis. The goal here is to come up with a set of rules to capture associations between items or events. The rules are used to determine when items or events occur together. A common application of association analysis is known as market basket analysis, which is used to understand customer purchasing behavior. For example, association analysis can reveal that banking customers who have checking or deposit accounts also tend to be interested in other investment vehicles such as money market accounts. This information can be used for cross-selling. So if a financial institution advertises money market accounts to your customers with CDs, they are likely to open such an account. Other common applications can be recommendation of similar items based on purchasing or browsing history of customers. Finding items that are often purchased together and offering based on these related items at the same time to drive sales of both items would be very beneficial. Identification of web pages that are often accessed together can also provide us a good basis for association analysis. One can imagine more efficiently generating offers on these related web pages to create further benefit of this information. We now looked at the different categories of machine learning techniques. They are classification, regression, cluster analysis, and association analysis. We've also seen some examples of each category. For the techniques we've discussed here, there are two ways of conducting the learning itself. These categories are referred to as supervised versus unsupervised learning. In supervised approaches, the target, which is what the model is predicting, is provided. This is referred to as having labeled data because the target is labeled for every sample that you have in your dataset. Referring back to our example of predicting the weather category of sunny, windy, rainy, or cloudy, every sample in the dataset is labeled as being one of these four categories. So the data is labeled, and predicting the weather category is a supervised task. In general, classification and regression are supervised approaches. In unsupervised approaches, on the other hand, the target that the model is predicting is unknown or unavailable. This means that you have unlabeled data. So you can't train using these labels. Going back to our cluster analysis example of segment customers into different groups, the samples in your data are not labeled with the correct group. Instead, the segmentation is performed using a clustering technique to group items based on characteristics of what they have in common. Thus, the data is unlabeled, and the task of grouping customers into different segments is an unsupervised one. In general, cluster analysis and association analysis are unsupervised approaches. In summary, in this video, we looked at different categories of machine learning techniques, and we discussed classification, regression, cluster, and association analysis as some of these techniques. We also defined what unsupervised and supervised approaches are in machine learning and which one of our earlier categories fit in these two categories.